So the first thing to do here is to draw the hexagon. And then we draw the circles. And so we have 6 circles, each of radius 1 around this regular hexagon with side length 2. And then the 7th sphere, oh yeah, these are actually spheres. I'm just drawing cross sections. And then the 7th sphere is internally tangent to all of them. And so we have that the 7th sphere has radius 3. Because I guess cross section has radius 3. And now we want to find an 8th sphere, which will be externally tangent to the 6 smaller spheres and internally tangent to the larger sphere. So we say, like, without loss of generality, the 8th sphere is centered at 0, 0, z. So it's it's straight up from the origin, which we let be the center of the hexagon. So it's straight up from the origin of the hexagon. So yeah, that's where this is like, this is the z equals 0 cross section. And this is like the x equals 0 cross section. This is like if we cut it vertically, whereas the first one was where we cut it horizontally. And so since we know that it's internally tangent to the largest sphere, we know that its distance from the top of this little triangle here is r, where r is the radius of the 8th sphere. And then we also know that the length of this, we know that the length of that entire segment is r plus 1, because it's r to get to the tangency point with the small sphere, and then the radius of the small sphere is 1. And we know that the value of this is 2, because this thing is 2. And then the total height is 3, because we know that that's the radius of the that's the radius of the 7th sphere. Why my sphere drawing skills are not very good. There we go. And so this is actually enough to solve, because we have now that 2 squared plus 3 minus r squared plus r plus 1. 2 squared plus 3 minus r squared equals r plus 1 squared. And then just solving this gives 4 plus 9 minus 6r plus r squared equals r squared plus 2r plus 1. So r equals 2/3. This one is quite a nice geometry problem. Yep, so part 1 was you first got the radius of the 7th sphere, and it had to be 3 because like the farthest point away from the center is going to be at like the edge. You can formally show it using the triangle inequality. Like this length here, the red length here is less than or equal to the sum of this length plus this length, which is 3. And then like equality holds out at the end point. So that's a formal proof. For the formal proof, I'll leave it, I guess. The formal proof that the 7th sphere has radius 3 is that any distance to any end point of the sphere distance from 0 to P on sphere is less than or equal to 2 plus 1 equals 3 by the triangle inequality. And so yeah, we get that the radius of the 7th sphere is 3. And then we set up the 7th sphere. And then after that, we just draw in the 8th sphere. And we have 2 bounds on it now. We have that if its radius is r, it's 3 minus r above the hexagon. And we also know its distances to the vertices of the hexagon in terms of the radius by the externally transient condition, and you solve. All right.